talk I'm going to give today is about how we use taxonomies in search to really build semantical search that a lot of people think requires really sophisticated machine learning. And I'm really happy that it's coming right after Ted Sullivan's talk, because a lot of what I'm talking about really dovetails nicely with that. There's so much you can do with Solr that doesn't require getting into the level of doing machine learning and those kinds of advanced things. You can do a lot just with the capabilities in Solr itself. So before I go any further, this is the shameless plug. This is who we are at Open Source Connections. You've probably seen us walking around with these bright green shirts. We are 100% focused on relevance. We take clients through the journey of getting to better search. These are the sorts of topics we work on. You may have heard of the Solr Learning to Rank plugin. We built the Learning to Rank plugin for another search engine that isn't prominently highlighted at this conference, if you know what I'm talking about. And just finished a big project with the Wikimedia Foundation to get Wikipedia search, helping them out, getting that up to snuff. So definitely talk to me if you're interested. And of course, for those of you who don't know, I wrote a book called Relevant Search. And if there will be discount code at the end, so you have to pay attention and look for that slide. So what I want to talk about is really, what do people mean? What problem are people trying to solve when they talk about semantic search? I think this is something that I hear people talk about a lot, like, I really want to build semantic search, and sometimes they'll say Google-like, and when you get into what Google-like means, it means like get beyond the strict text token matching and onto understanding concepts. And out of the box, it sounds like a really fancy machine learning kind of thing that you're going to spend, $500,000 to go buy Coveo or something to build this brilliant, amazing thing, or you're going to have to get involved in deep learning or something. So a lot of what people mean when they talk about this semantic search problem gets back to this paper that my colleague of mine, Renee Kriegler, shared with me, which is basically this idea, and this is an old classic paper, that for human language systems, human beings, if you show an object to two human beings, there is a really small probability they will use the same language to describe that thing. Do you have an orange or a tangerine? Do you have is it maroon? Do you use some specific language, or is it just brown or reddish? There are so many ways to describe things, and this is where we struggle, because we know that in, say, merchandising, merchandisers, content creators tend to use language, and then someone comes along and searches, and they don't use that language. They use their own way of describing your products and inventory. And that's really, to me, before you get to any machine learning or anything, the fundamental challenge to search is really that the language your searchers use and the language your content uses are not quite often very different. And so this talk is about mapping those two worlds of how searchers talk about things and how your content creators talk about things. And before I go on, I mean, how many people have seen keyword stuffing before, where you get this problem and so you're, well, I need to add maroon, brown, red, any conceivable color to this product so that it will come up for my searchers. And this tends to create a giant mess, right? Because A, people aren't particularly consistent. B, people who stuff keywords don't understand TF-IDF, and it tends to skew statistics in really weird ways, where this common term, I used it 5 times. Why is this rare term I stuffed only 1 time, meaning more? And you have to get into this whole discussion. And you're really going against to the actual structure of language, which is very much what TF-IDF gets at, that some things are rare and some things are common. So, and it's spammy. If you have merchandisers and they're incentivized, for example, to get their product sold, you're going to have one merchandiser who just loves this and is going to spam the heck out of your search engines, right? Your searchers are going to get nothing but their products, but they're probably not going to be relevant. Tagging is very similar solution to this. If this is just a random Stack Overflow question, it'd be really hard to tell what this is actually about. So it'd be really hard to actually use this necessarily for a search beyond like a category search if I want to look at Java questions. There's also no sense of like Java is a JVM language, or there's no synonymic hypernym, hyponym relationships. And finally, you really need consistent tagging rules to get tagging to work. And I could do a whole talk on tagging, but for the most part, tagging is sort of a dead end unless you're getting really strict with it. Finally, we all jump to synonyms, right? And I can't tell you, in the clients that I help, I see these sorts of things all the time where you have someone at the company makes wingtips a synonym of shoes, or makes tennis shoes a synonym of shoes. And then all of a sudden, when I'm searching for wingtips, I'm getting tennis shoes. Or even, when we're, depending on how we're dealing with synonyms, we could have this shoes to dress shoes, and all of a sudden, when I search for shoes, I get dresses. And so you get these situations, and you have to, synonyms can be an amazing tool, but you really have to develop a really strong discipline and practice around using them as a tool, and they can really get you into a lot of trouble. So when we step back and we think about these semantic search use cases, I like to think about how users talk about our content. And in the examples you've seen so far with shoes, you're sort of noticing that there's this hierarchical relationship. Shoes go to dress shoes, go to brown wingtips. As people search, they often remember how to talk about your content. They'll see your content. They'll say, oh, that's the search term I want to use. Or they'll add modifiers. And this is a very human thing. And you see this in conversations too. Something's on the tip of your tongue. You start talking with somebody about a problem. All of a sudden, the parts of your brain that remember how to talk about that problem start turning on. And all of a sudden, you become much more of an expert at that problem and use more sophisticated language. So there's a hierarchy here in language. Language is very hierarchical. And, a 3-year-old will know the word shoes. A very sophisticated Brooks Brother shopper like me and my colleague Bertrand will know what wingtips are. You gain expertise, you get more specific terms for things. You get narrower terms. There's Oxfords, there's wingtips, there's loafers are arguably a kind of dress shoe. And then there's like my dad who just like knows he needs dress shoes sometimes when he goes to a wedding, right? He doesn't think about all these categories. So it's a very hierarchical relationship. And you can see that there. Wingtips are a type of dress shoe or a type of shoe. And the other thing you start to discover is you have specific kinds of modifiers you apply to searches. And I'll step back and just say I'm mostly talking about there's a lot of different search use cases, and the Baymard Institute, which is a UX, I believe, consultancy or something, breaks down e-commerce search use cases. And I'm talking probably about half of them, but there are stuff like known item searches, which I'm not really talking about, which is like you have to look up something and you know the exact model name or a part number or something. This is very much like the kinds of searches I see people frustrated with when they're talking about semantic search. Categorical, refining into specific colors, and those sorts of things. So we add modifiers. So how people are searching, how people are refining, they're continuing to iterate on how they're using the search. And you get in these two categories that really, I think, define what people actually want when they want semantic search. They want to be able to solve the left side, and they want to be able to solve the right side. On the left side, you have searchers who are not specific enough. I have a blog article where I talk about searching for a laptop bag. And when I searched for laptop bag on Amazon, I was suddenly aware that there are kids' laptop bags, there are hipster laptop bags, there are laptop briefcases for the business person. And what I actually wanted was something more specific than that. And giving me like a broad overview lets me see what's possible. So we want to expand out and diversify. On the other hand, when we're too specific, let's say we have that expert high-dressed searcher who comes in and searches for Oxfords, we may want to step back to get a little bit, go from a very high term specificity situation where Oxford is a very expert term, and we might want to widen it a little bit. We may want to pull in other kinds of dress shoes or specific kinds of dress shoes that are highly related to Oxfords. Without those products actually mentioning the term Oxfords, right? We can show them, at least we know you're talking about dress shoes. So we can sort of back out of that very overly specific, overly refined language. So the goal, my goal whenever, especially in a lot of contexts, is I spend a lot of time when I do relevance work trying to make Solr really understand these sort of type of hierarchical relationships. You know, we've said this before, wingtip is a type of dress shoe, is a type of shoe. And these are the kinds of use cases you're trying to get out. And going beyond just, you know, we're talking mostly in this upper category of hierarchical relationships, shoes to more specific kinds of shoes to even more specific kinds of shoes. And there's another level too, which is the modifiers themselves, the sort of entities, the ways people select also come with their own taxonomy. So you have colors like blue, and there are types of blue. You may have brand names. You may have other things that people are using to really select from your inventory. And you almost think of this much like sort of Ted was saying, is it's almost like, it feels almost like when I'm constructing a select query, these are like specifiers for what I'm looking for. They're descriptors to get at that content I'm trying to find. So there's two approaches I'm going to talk about that I find really useful when dealing with these things. So I work with a lot of companies, organizations, and I will also often, just me taking the time, I had a client who was basically indexing all of Shopify's apparel data. And it was a startup, and in something like 80 or so hours, I was able to use some tools that I'll talk about in a little bit to come up with a taxonomy that gets at these like relationships. And you can see here, we've got one that's like, in our item, we have tennis shoes. And we have sort of a place in our taxonomy for that. We've got footwear, which has shoes, which has various types of shoes, in this case athletic, in this case tennis shoes. And the same thing with Sapphire. So how can we do this? At index time, what we can do is we can break these up, and this is actually a place where the auto-phrase token filter can also help. We can break these things up and create copy fields. If we have a description field, we can create copy fields and really think about how we're structuring our documents for query understanding so that we're pulling out the kinds of things people select on in our content. So it's a data modeling exercise, and quite often a lot of relevance is a data modeling exercise where you're building out fields not because how your source data model is structured, because you're trying to support specific kinds of use cases. So let's say we take our product description and we have 3 copy fields, item, color, size, because these are the kinds of searches we need to support. And let's only keep the things in items that are verifiable item phrases. Tennis shoes, dress shoes, wingtips, beyond shoes, we might have, dresses and pencil dresses and little black dresses and those sorts of things. And the same thing in color. And people often know what stop words are. Keep words is a tool that we use a lot to do basically very quick entity extraction from these terms. I don't think it's necessarily as popular as, people take stop words out all the time, often when they shouldn't actually do it. Keep words is actually an amazing way to load up your search engine, make it an entity extraction system to do a lot of data modeling around how your users are going to search. And this is basically, if you ran a product description through the analysis chain, you could get something like this. First, and I tend to build this out a little bit programmatically, but we take our phrases, in this case dress shoes. First thing I do is I make sure we compound or decompound so that our noun phrases like dress shoes or idiomatic these sort of idiomatic noun phrases that people use, the collocations that are just so common that they're idioms, that we make those their own term, so dress underscore shoe. Then we keep only those things, so we keep our dress shoes. We throw away everything else. And the same thing we do down here in color. You can see we keep maroon. We keep dress shoes up here, we got maroon down here. So we're already building out almost in the same way you would deal with a relational database. You're selecting across these different aspects. And then finally, what we do is a semantic expansion up the category. So dress shoes expands to shoes. It's dress shoes and shoes. If we had wingtips here, we could go wingtips, dress shoes, shoes. We might have an even more specific kind of maroon. We'd have 3 levels here. Or we might just say brown. And this is actually a pretty phenomenal, there's a really phenomenal characteristic here, because if you think about how this works, is we're actually working with the structure of language and how TF-IDF scoring works. Because what's going to happen is shoes is going to have a really high, or it's going to have a really high document frequency and a low IDF. So someone searching on shoes, that's going to be fairly low value, as our searchers would expect. But if I'm really specific and I'm searching for dress shoes, there's fewer, because it's lower in this concept hierarchy, there's fewer documents that are actually going to have dress shoes. And so its document frequency is going to be a bit lower, and it's going to score a little bit higher. And the same with our colors. So we basically create, and this is basically how we search. Of course, we would add more fields than this. I'm editing this down. We're basically creating a situation where if I search for wingtips, I'm going to get, and you can actually decide at query time how wide you want to expand that. You may not want to expand all the way to shoes if that's going to look bad. But for this case, I left it on there. But if I'm searching for wingtips, and I expand to wingtips, dress shoe, shoes, and I have wingtips, dress shoe, shoes, because of how TF-IDF works, first I'm going to get wingtips, then I'm going to get dress shoes farther down in ranking, and then I'm going to get any shoe. I'm going to start seeing my tennis shoes and other things that have a parent concept of shoe. And the same thing for color. And we're really sort of data modeling for how people think about and structure the content when they search. And this is a really powerful, easy to implement thing that doesn't require starting a learning to rank project or getting word to vector work or any of that stuff. Now, index time is one way, and I'll talk about the pros and cons. Another way people do this is with query time expansion. Query time, you can see here that, and a lot of people probably have done similar things, where we're taking our phrases and we're starting at tennis shoes, and we're broadening out semantically tennis shoes, athletic shoes, and the same thing with our colors. So similarly, we have our input text. I'm skipping over a lot of the intermediate steps that are about the same. We take our query phrase, and we do semantic expansion for it, again, as far up the concept hierarchy as we feel is necessary. And this is, we can get these kinds of, this effect out here. Of course, one thing that is kind of problematic is what I would like to do sometimes is if I have this item in color analyzer, but wouldn't it be great if I didn't have to somehow, one thing you sometimes will have to do if you want multiple query analyzers on the same text in Solr is you just have to copy your text a bazillion times. And annoyingly, what I would prefer to do is take this brown wingtips, only search at my description field, and not have to have all these copy fields, but select at query time which analyzer I would like to use, which is something you can do in Elasticsearch, dare I say, is you can go and you can pick out the query time analyzer and change it at query time. It's not something you can do as easily in Solr. So I would like to transform this, to description with those phrases. And the other thing I would like to do is some of my synonyms that have spaces for, and this is something you can't really do in Solr or Elasticsearch other than this plugin I'm going to show you, is I would like to turn that into a phrase query. Dress space shoes. I'd like to search for the phrase dress shoes because I know that's a noun phrase without having to do the index time stuff. If I'm in this query time world, I don't want to have to do the same kind of data modeling I was showing you before. And we have this match query parser that we use as part of the sort of Swiss Army knife I use a lot in Solr, where I will say, I will give a field type, a Solr field type, to say, go fetch the query analyzer from this Solr field type in the item taxonomy, color taxonomy, whatever, and then search with. I can either search it as terms, or I can take retokenize. Basically, I think I only allow the standard tokenizer right now, but retokenize and then research with a phrase query, so that you get this this effect here, where you dump out these terms out of the query analysis, and then dress space shoes can be tokenized again, and we turn that into a phrase query for quote dress space shoes. And this is basically how you could do, how I often do query time semantic expansion. Pretty straightforward. Now, there's a lot of other building blocks. Ted's talk was amazing. The autophrase token filter and the query autofiltering is another thing. And this is a common thing. These kind of trying to turn unstructured and quote-unquote queries and add structure to them are very common themes. And there are other things out there. The health on net Lucene synonyms, some of you may have used. That's like the long-term fix to the synonym problems that Solr has had until recently. And then Semantics is a query segmenter that is similar to the query autofilter. A colleague of mine and good friend Renee Kriegler has this tool called Quirky, which I think is something else you should check out. The GitHub repo's cut off there, but basically Quirky is a query preprocessing system that can do this kind of semantic expansion. You can see on the left we've got a taxonomy that we're working with. And what he's doing here is Quirky is a preprocessing rule system that says take this keyword, say computer, and expand it to these other phrases. And it can do a lot of sophisticated thing based on wildcards and how many terms are in the query and all kinds of stuff. And what it's doing is giving an option to do synonym expansion. I definitely recommend checking out Quirky. It's extremely powerful. It can do things like add boosts in the case of computer. If someone types cheap computer, you can automatically filter to the certain price range, those sorts of things. Really powerful open source Solr plugin. So the pros and cons for this. Query time. I think query time is often a lot more easy to manage if reindexing is painful. So large data sets, or for some reason reindexing is painful in your environment. The cons are you don't get the same TF-IDF sort of effect I was talking about, where you get very specific things get scored much higher. I mean, you can obviously play with boost to get that. And you can build large complex queries. So you can build, if you really expand to a lot of different semantic concepts, you can build large queries. Index time, the pros, the TF-IDF scoring effect is that is magic to a lot of people because you really are scoring based on semantic proximity. Concepts that are closest get the highest score. Siblings get a score approximate about the same as a parent concept. And then the next parent out gets the lower score. And it's a really amazing, turns into basically a semantic scoring system. And the queries are faster because you're not doing the same level of expansion potentially. And of course, you have to reindex if you change your synonyms. Big takeaway here, either case, I think it's really important to figure out how you're structuring your content for findability and query understanding. And I'm not going to go through all of this, but this second to last bullet here is something I think about a lot lately. Is a lot of search problems come down to how are people who create content and manage content, are they actually incentivized by the organization to make things findable? In a lot of enterprise search contexts, the person who wrote the document has no incentive to make it findable by someone else. So to me, that's one of the most fundamental problems of enterprise search. Conversely, in an e-commerce situation, quite often, if you have a merchandiser, they may be incentivized to make their stuff findable because they may be driven by metrics. Of course, those incentives can go skew things even worse if, in the keyword stuffing example, if you have a malicious merchandiser who's, but not necessarily malicious, but they're out for their own dollar bottom line, they're going to stuff keywords and do all kinds of crazy things. But you see me do all this stuff with taxonomies, and what I want to talk about for the next 15 minutes is how you can begin to build these taxonomies. You can gain a lot of progress just by looking at some of the existing taxonomical things on your site. Use filters and facets on your site. Your site probably has a navigational taxonomy for its menu. That was actually really powerful when I was working with Shopify data, because people running their storefronts would actually organize their content. It wasn't a lot of content per site, so they would do a pretty good job of organizing their 100 or 200 products in a reasonable navigational structure, which helped as a seed for this stuff. I'd also say that any of this stuff, one of the most important, you've heard a lot of technical talks here, but I will encourage you, if you are a small to medium organization, working with domain experts, library science, taxonomists, they really understand how to take something like this and potentially turn it into something that can make search amazing. I think library science, as my colleague Peter Dixon-Moses likes to say, is one of the most underappreciated fields, actually, when it comes to search. So all of this stuff is sort of input, but a human who is probably a domain expert is going to need to review this stuff. So finally, I want to talk about something that I like to use sometimes, even sort of informally, but this is a bit more formal representation of it, is this algorithm called the Shrek algorithm, which is a way of mining hierarchical relationships for terms from both content and query logs. And it's dumb simple. It's something that is relatively straightforward statistics. And you may have to stare for this a while to figure out what it is, but a Venn diagram basically helps. If all of our shoes and wingtips is basically most of this bubble there, shoes is basically subsuming wingtips, and df here is the document frequency. We can go and say, we can possibly say wingtips is a candidate child concept of shoes. And just like Ted said, facets are an amazing tool, and I think this starts to be where his talk dovetails nicely with mine, because you can start to explore these kinds of relationships, hierarchical relationships, just by using facets. And I'm going to show the dumb version. You probably want to use the terms component for that. But this is the dumb version. You can get really deep into this. You can go and, you're like, oh, I'm going to do all these faceting all the time. Basically, if you take your corpus and do this kind of thing once, you can start to derive, it's more of a data exploration thing than something you're doing on every user request. But you can start to explore and figure out, okay, I can get the document frequency of shoes, wingtips, by simple faceting. And then the shoes and wingtips, that's literally just that query and getting the number of results. And I can do this math, and I can run the Shrek algorithm with Solr to figure out how my concepts are related. Unfortunately, reality is messy. And especially when you have merchandising, e-commerce data, you have relatively structured, not lots of paragraphs sorts of search problems. This quite often someone will say, you should buy these wingtips, or really nice wingtips. And if you're just looking at product titles, for example, it's not going to say wingtip shoes. It's probably going to say wingtips. It's punchy. It gets at it. And even the 3-sentence product description might just say wingtips. So your data is more like this, right? You can go and download Wikipedia potentially and try another corpus to see if you can figure out these sorts of things. There's no reason that your corpus necessarily has to come front and center. Of course, the things you want to know about are specific to your domain, so just grabbing Wikipedia might not give you what you want. You might need something more specific to your domain to understand these, but you could experiment with that as well. Another thing that people often do is just simple. One of the problems with this algorithm is once you get here, how do you get here? How do you know wingtips is a thing you should test against shoes? So that's a fundamental problem, right? How do I know, like, why didn't I search for tips, like, I don't know, beef tips? Like, oh, because I'm a apparel site and there's none of that's in there. And it turns out that there are ways to look for statistically, you may have heard the term statistically significant phrases. There's another fancier term, statistically significant collocations. And I've got to get better at drawing Venn diagrams, because I literally threw this slide together an hour ago. But there's some, if you go actually look up the Wikipedia article on this, this is a really straightforward thing you can run just with basic statistics, basically testing the null hypothesis that wingtips is not a idiomatic phrase, that wing and tips occur independently with some probability higher. And you can use this to seed possibly things from your corpus to say, these are phrases I need to look at because they're really important in my corpus. And of course, this is something I think you could start to also build with faceting. And Ted's talk was actually really good at, Ted should really do a TED talk, by the way, because that would be great. Ted's talk, yeah. You could look at his talk to pull out even more key phrases. But what I'm really excited about, a lot of stuff that people look at for deriving synonyms, hypernym, hyponymic relationships are focusing on corpus. And the other half of that Shrek paper is talking about refinements. So we have all of these ways that people refine their query. There's a lot, if you go and Google query graphs, there's a lot of research on analyzing query graphs. And you can use this to see how people, just like I was saying before, people start with simple queries quite often, and they will refine to more specific queries. They'll learn the language they need to be using to get at your products. And you can sort of see these patterns, like you generally see the sub-concept dominate the, only under a parent concept with high probability. And for modifiers, you'll see them all across, not necessarily just under one root of the tree. You'll just see brown for everything, right? And you can look at this and start to think about different categories of ways you can look for these patterns. And Shrek actually has a way of doing this, which is basically to score based on how often we see these refinements. And you can see here, we can actually just do this in Solr. We can use Solr as an analytics engine. And we can basically throw in what our start query was and what the refinement was. And we can start with something really simple. Query with shoe, the facet, we want a facet on refinement. And we can see, okay, what phrases came up most after shoe. We can see dress shoe, tennis shoe, and those things. And we can start to see, okay, there's a potential that dress shoe, tennis shoe are child concepts of shoe. So Shrek with refinements, Shrek does this scoring. You saw the scoring it did before with the document frequency. But what the Shrek with refinements algorithm does is takes that and goes and figures out, okay, how frequently does a refinement go from shoe to, say, dress shoe versus all the other ones? And again, these are statistics you can pull out through, these are stats you can pull out through facets, right? You can get this information, and you can start to basically add a weight. In addition to the weight from the corpus, you can say, okay, for the shoe to dress shoe node in my graph, I can weight it even higher if I also see it in the refinements. Or I can use this to start a graph of how things are refined, and then I can look at my corpus based on the document frequency, and I can use that as a way to sort of amplify that or add to it. You can start to build a taxonomy and really hints for what things should, how you should build your taxonomy. So a lot of what Shrek is doing when it's doing the simple division here is significant scoring. And I just wanted to point out that if you're using streaming expressions, you can do this what's called a significant terms facet. That if you see any of the talks on streaming expressions with like recommendation systems, basically what this is saying what queries are recommended for this root query. And if you look at the original Shrek paper, what the Shrek paper is basically doing is saying where they're actually doing query recommendations. They're not actually building taxonomies. But this is sort of another way you can do to get at that statistical scoring without even have to like pull out the document frequency of everything, keep it off to the side, and like remember what it is as you go and explore this. You can do this in one call. So if you're interested in this, and mining refinements is a really rich field that a lot of people are using for relevance to get hierarchical relationships. Of course, Trey's talk was amazing. He's doing a lot of stuff with the knowledge graph to really get at that. And a parallel technology that sort of was invented independently is in Elasticsearch. There's elastic graph and significant terms aggregation, which does some similar stuff that you might want to check out. And specific to Mark Harwood's talk, he actually shows in the elastic graph product them looking at different refinements and starting with a ambiguous query like Blender and going out to like Blender as the audio equipment or Blender as the kitchen item. And so looking at refinements, you can see those ambiguities. And it can be a really great way to just start to fine-tune your search by seeing how people are doing that. So Word2Vec, LDA, a lot of people are thinking they can derive their synonyms from Word2Vec and LDA on their corpus. Latent semantic indexing is another one. This has a couple of problems. I mean, obviously it's focused on, quite often it's focused just on the corpus. And quite often gets more at co-occurrences. So Blender occurs a lot with, I don't know, ice and fruit. Not necessarily synonyms, but can give you some insight into related concepts, possibly for some kinds of semantic expansion. So I finished with 2 minutes left, and as I promised, there's a discount code. So thank you. And there's a bunch of blog articles here that talk about a lot of these ideas that I really definitely recommend that you check out. So, yeah. Mm-hmm.
Not just synonyms, it's just finding noun completions. But if you use the same tokenizer that I use for the query keyword clustering,
Mm-hmm.
and put out a word of that becomes thing to that.
Yeah.
Because if you tell it, you already know that network adapter is the thing, then it will find other things like network error or network bandwidth.
Mm-hmm.
So actually, Vlad was just done a Convo, my friend TC is in Convo. And so basically what I learned in that is that phrasing as an input to some of these engines
Oh yeah, definitely.
makes them more semantically relevant.
You actually have to do, and that's a really good point, because
And the other thing, Doug, is
yeah.
I guess I bashed TF-IDF. I hadn't thought of that
Uh-huh.
that's pretty cool.
Thank you.
Down the show somewhere.
Okay. That's a good point about Word2Vec. Word2Vec is many ways like search. You have to sort of do some data modeling to get good stuff out of it, like what are your concepts? And then you get like some rich and even richer information out of it. Any other questions? Yeah.
Talk a little bit about how you want to leverage domain expertise.
Mm-hmm.
Experts in building these things. One of the challenges we've had is, obviously the people building these taxonomies don't have that. Do you have any best practices or tools for enabling non-technical people to contribute?
To something like this kind of taxonomy? Yeah, so I like to think that as developers, we're not building search for users, but we're building search for the product people who are going to build search for users. And so what I might say, and this is quite often what happens is, I mean, there are things like pool party and that kind of thing for managing taxonomies, but you might want to think about how am I building a user experience so a product person can influence search with something like a taxonomy change and understand the kinds of effect it has on them, it's going to have on search. And I will say it's non-trivial because you will have to educate them based on what strategy you choose. So like the technologist's job is to figure out which of these strategies make sense for your business, and then figuring out a way to sort of expose that without having them go through Solr configurations. But maybe there's a way that start out with like sitting next to the domain expert and you're sort of editing the taxonomy and explaining the consequences of decisions. That's often like the lowest hanging fruit. Up to, I've seen organizations that build out like semantic tools to manage their taxonomies. And it's often like those sorts of things are business gold. Like that is often like the stuff that makes a business swim or sink. And it's a lot of their own intelligence and business knowledge in it. So, yeah.
So the Shrek algorithm, I was curious, have you ever used like, or thought about using like clickstream information or anything like that to further, like it's basically just set comparison. So to further refine it or filter it, or and how much accuracy or error is there?
So to see if someone like searches for dress shoes, but they click on a Wingtips thing to see that is, there's a lot of research about doing that sort of thing, where you're looking at how, actually Trey Granger has a paper he wrote on this about how he did using how refinements hit documents, did some level of, I think he used latent semantic analysis, combining those. I will say that I like looking at refinements and the corpus like in this way because quite often if you're looking just at click streams, people may, if your search is bad, they might not be clicking on things that are relevant to that. But yeah, I think and click streams also have issues with potential bias. What could be,
If you overlay the two approaches, is that ever
yeah, I think you could overlay the two approaches, yeah. So it could be interesting to like do something where you're doing, it's a little bit of like catch-22, but you might do it to like validate what you're doing. So like if you did the index time side of this and you had sort of concepts in your index and you did someone clicked on something after searching a different, or the same context, you're getting validation and different, so a common strategy people will do is like keyword stuff based on clicking. They'll like there's actually a Rails library called SearchKick or something that does this with Elasticsearch where it just keeps stuffing keywords. But I've also seen that like potentially hugely biased search in bad ways. Yeah. Oh, really? I missed that talk. Yeah. Uh-huh. That's true. Yeah. Any other questions? Oh, good point. That discount code is good for Manning.com. Yeah. That's why no one buys my book.
I bought your book. My product manager stole it though.
Now you need another one.
Yep.
Any other questions? I think I might get kicked out. Thank you.